Hello, welcome to Day 1 Notes, the second part of 6.1, Operations with Polynomials. Today what we're going to be doing is adding, subtracting, and multiplying polynomials. So let's begin by defining a polynomial. It's an expression that can have constants, aka numbers, variables, and exponents that can be combined using addition, subtraction, multiplication, division, but here are the two things that cannot happen. There has to be no division by a variable raised to a positive exponent. So if there's an x in the denominator or a y squared in the denominator, it's not a polynomial. And the variables exponents can only be numbers such as 0, 1, 2, 3, etc. So no decimals, no fractions that don't divide to become a whole number. Okay, so the first thing we're going to discuss here is the degree of a polynomial, and what that is it is the degree of the monomial with the greatest degree. So recall that a monomial is just one term, so something like 5x or 7x squared y to the third, that's a monomial, so it would be the degree of the monomial that has the greatest degree. So for example, the degree of x squared minus 4x plus 62 would be, well, the degree of the first term here is 2, the degree of the second term is 1 because x is raised to the first, and the degree of the last term, there's no x there, but really I could put an x to the 0 because remember that would equal just 1, so the degree of the last term is 0. So the highest degree of the monomial is the degree of the entire polynomial, so in this case it would be 2, because that's the highest degree. Okay, so the first part we're going to determine whether each of the expressions is a polynomial, and if it is, we're going to state the degree of the polynomial. So remember, the two things that cannot happen that would make it not a polynomial is if the exponents are something other than 0, 1, 2, 3, 4, etc., or we have division by a variable and that degree or the power of that variable would be positive. So looking at this first one, we have c to the fourth minus 4 times the square root of c plus 18. So the first exponent is 4, so that's fine. The second exponent, you guys technically don't know this yet, but if you have the square root of something, that's like it's raised to the power of 1/2. So automatically that makes it not a polynomial because that exponent is not a whole number or 0. Okay, part B, we have negative 16p to the 5th plus 3/4 p squared t to the 7th. First thing I look for, no division by a variable to a positive degree. Secondly, I have to look and make sure that all the exponents are whole numbers. So the first one is 5, then here we have a 2 and a 7. So neither of those two rules are broken here. So now we're going to find the degree of each monomial. Well, the first monomial is negative 16p to the 5th. That degree is 5. The second one is p squared t to the 7th. That degree, what you would do is actually add those exponents, so it's 9. So this is a polynomial, and the degree is 9. What I want to bring your attention to is this 3/4 here. You may be thinking, well, I thought you said it can't be fractional. Fractions are okay as long as they're coefficients. If that was an exponent, that would automatically make this not a polynomial. So if we had a variable raised to 3/4, that makes it not a polynomial. Okay, go ahead and try part C on your own. Pause the video and then check your answer. Okay, so for part C, you should have gotten that it is a polynomial. There's no division by any variables to a positive degree. All the coefficients are whole numbers, so the degree there is 7. If you do not understand how that answer was obtained, make sure to ask your teacher. Alright, so the next part here is we're going to be simplifying these expressions. So you could simplify a polynomial just like you simplify a monomial. So we're going to perform the operations and combine the like terms. So that's when it's completely simplified. So the first problem here, we have negative 3x squared plus 7x minus 4 plus the second polynomial, which is 9x squared minus 4x plus 10. So we're going to add like terms. So first thing I see is an x squared, and there's negative 3x squareds, plus we're going to add 9x squareds, giving us 6x squared. Now, you don't do anything with the exponents. Don't add them together because we're not multiplying these. When you're combining like terms, all you're doing is combining the coefficients. The exponents stay the same. All right, then we have a 7x plus, you could think of it as a negative 4x, so that would give us a total of 3x plus 3x. And then our constants, we have negative 4 plus positive 10, giving us a plus 6. Right, second one is almost the same, except now we're subtracting the two polynomials. We have 7x squared minus 3x minus 1, and then we're subtracting 2x squared minus 5x plus 3. So just like with matrices, when we're subtracting matrices, when I see a subtraction, I like to change that to an addition sign and then put the opposite of everything that was there. So the 2x squared becomes negative 2x squared. We add 5x, and then we subtract or add a negative 3. And now it became an addition problem. So we do 7x squared plus negative 2x squared is 5x squared. Minus 3x plus a positive 5x would be plus 2x. And then finally our constants, we have negative 1 plus a negative 3 would be minus 4. If you want to write that as plus negative 4, that's fine as well. Okay, so part C, I would like you to try on your own, so please pause the video and attempt that problem. There's the answer that you should have gotten. If you don't like switching that middle sign to a plus and then taking the opposite of every term in that second polynomial, if you remember to, subtract everything from there, that's fine as well. However, I do find that a lot of times kids forget, like they'll add the 2 on accident, so they'll get one of the terms incorrect. Okay, in part D, we're going to have a monomial, and we're going to multiply it by a polynomial. So we have negative 2d times negative 2d cubed minus 11d plus 20. All we're going to do here is distribute. So negative 2d times negative 2d to the third is a positive 4. We still multiply coefficients like always. And then properties of exponents, if we have d times d to the third, we add the exponents, so it would be d to the fourth. Then we're going to have minus 2d times negative minus 11d, so it's plus 22, and again we're going to add those exponents, so it's going to be d to the second power, and then finally negative 2d times 20 is minus 40d. In part E, we're multiplying two polynomials, so we have x squared minus 3x plus 6, and then we're multiplying that by 2x minus 3. So you can, if you want, distribute. So you could do x squared times 2x and then x squared times negative 3. Then you would do the second term of the first polynomial, multiply it here, and then you could finally do the last one. And then you would have 6 terms. You're going to combine like terms. However, I think drawing that box and multiplying that way is a little bit easier. So you would write the terms of the first one. So x squared minus 3x positive 6, and then on the side here we're going to write 2x and then a minus 3, and within the box is going to go each product. So the first square here is going to have x squared times 2x, which is 2x to the third. Second box is going to be negative 6x squared, and then a 12x. In the second row we're going to have negative 3x squared, then a plus 9x, and then a negative 18. Okay, so the way we write our answer, we're going to combine like terms. So I have a 2x to the third, no other x to the third, so that stays as is. Then I have a negative 3x squared and a minus 6x squared, that's minus 9x squared. 9x and a 12x, we're going to add those, it's 21x, and then a minus 18 for that one. Okay, second example on this page, we have a plus b times 2a minus 4b times x plus 3y. So what I like to do is multiply the first two together, because when you have three things that are being multiplied, it doesn't matter which order you multiply them in. So I'm just going to multiply the first two. I'm going to get 2a squared minus 4ab, which would be the same thing as 4ba, but I like to write it in alphabetical order. Then I'm going to do a second term. So b times 2a is plus 2ab. And then the last one is going to be minus 4b squared. So I'm going to clean this up. I'm going to have 2a squared minus 2ab minus 4b squared. Now I still have this third binomial that I have to multiply in there, so I'm going to draw my box and put those terms here on the side. I'm going to have x and 3y. And find the product. So the first one's going to be 2a squared x. The second one's going to be minus 2abx. Last one here is going to be minus 4b squared x. Second row, 6a squared y and negative 6aby. And then finally, negative 12b squared y. Alright, so I'm looking for like terms. First thing I see is an a squared x. I have two of those. So I look through and see if there's any other a squared x's. There's not, so I just bring that term down. So it's 2a squared x. Done. Next I see a abx. Looking through this, I don't see any other abx's, so it's just minus 2abx. Then we have a b squared x. No other b squared x's, so it's just minus 4b squared x, and I'm going to run out of room, so I'm going to write this below it. A squared y, no a squared y, so it's going to be plus 6a squared y. aby, no other ones. And then finally minus 12b squared y. Okay, so that one was kind of unusual in the fact that there were no like terms at the end. Typically that doesn't happen, but if it does, oh well. Okay, pause the video and attempt part G on your own and check your answer with mine. Okay, so there's the answer. Hopefully you got it. If not, please make sure to ask your teacher in class. And that's it for today. It's kind of a combination of combining like terms where you don't do anything with the exponents, you just combine the coefficients, and then also the properties of exponents, where in this case a lot of times we had to just add the exponents together when multiplying the monomials. Thanks for watching. Have a great day.